Start recording. Hello, everyone. This is 8:30 p.m. on June 27th, and we're about to go into Debbie's data. So I'm going to plug the display in, and we'll turn it over to her, share the screen. I hope we share the screen, and share screen. And then hopefully all of you out there can see the screen. And if we go back to SPSS, we did. And if it's not posted, go into the news forum. I think I clicked distribute to everyone, but I might be mistaken. So go into the news forum, the last posting in our Moodle place. And oh yeah, I just posted it, and is it not there? Yep. It's there. Okay. Okay, so is the font big enough? Everyone, I think we're running in Zoom, and I assume it's recorded there. So I'm going to turn this over to Debbie Cockerham and let us go with our data. Debbie, what is it?
So I'm doing the STEM semantic survey, which was done by a very famous statistician over here, Dr. Knezek and Dr. Christensen.
Oh, A+ for Debbie.
You tell me I'm not plagiarizing to use it. We did it with 128 Sanger Middle School students, both before and after they did a 3-week historical inventions of STEM, looking at STEM concepts. So this is with Dr. Tyler Wood, and looking to see to what extent the unit increased student interest in the different STEM subjects and STEM careers. So in the data file, the questions are, so the names are on the left and it goes into the questions. So STEM S are science questions, and then it goes to STEM M, which is math questions. Yes, I gave everybody one.
Yeah. Okay, great.
In case you don't remember. STEM E is engineering interest, STEM T is technology interest, and STEM career is interest in a STEM career. So the first thing.
Hello. Oh, I don't know. Someone else.
Yeah.
So, I know, Jim, but that's a good idea. Ought to be.
It's a great idea.
Yeah. Okay, so I'm sorry.
Okay.
Go ahead.
So the first thing I did was to reverse the negative question values. So you have my copy of where I was just making notes, because I didn't have one with that where I had marked. So you can see which ones I reversed so that the numbers were all aligned on them. So I have, at the end, I have of the file, I have the reverse. So you can see the reverse columns that I used for those. And then I went back through and grouped them into categories. So I also have a category for each subject. So STEM Sci is the total of the means of the section that's interested in science, which is questions 1 through 5. So there's a category for each subject and careers. Does that make sense?
So everybody understands. So she produced those by averaging 5 after reversing the ones that were reversed.
Right.
So this is scale scored, classical scale scored.
Right.
Okay.
And then I went through and did reliability ratings, and I did those with each of the subjects, and I did it with each of the categories. And with each of the subjects, it was very high reliability, so we had them really aligned well. They were all the lowest one was 0.86, so very high reliability. But with the categories, it was 0.6, which is a borderline. reliability. Okay, so I assumed that if I did a factor analysis with all of the questions, it would come out just lining them up. So 5 factors are the different 5 areas. So what I did was to use the averages when I did the factor analysis. I don't know if that was correct or not, but that was the way I lined them up. So is that, you want me to do that?
And actually, if I could, Debbie, if you don't mind, since she's already produced the scale scores for each of these, this is a really super example of where we can go through all 3 techniques at the higher order analysis. So the question is science more closely related to engineering or math, for example? And is this okay, Debbie? Mm-hmm. So the first thing we're going to do is a higher order factor analysis. We'll pull down the data. So we're going to do a regular factor, and we're going to put the factors in and factor out. Okay. And there will be 5 factors, 5 scales that we know represent these 5 constructs.
Okay.
And so we're going to, this will be the average of the total of 5 whatever the scale is. I'm sorry.
I just want to see which ones were reversed because I didn't keep a copy.
Oh yeah, no, not the reversed ones at the end.
You let me do the 5 categories.
Yeah, the 5 categories. So for example, the one that's the science score.
Okay.
So here to be STEM science we're putting in there. And you recognize that the average across the first 5. And then STEM math will be in there and all of those. All the way, and put STEM career in there too.
Yeah, but I had to redo it because I missed one when I went there. So it's the edit there.
So these, and now we're going to do extraction, just like before, and we'll go ahead and go with principal components, and then based on eigenvalue 1, we want a scree plot. Since we're doing higher order, we're not going to pay too much attention to eigenvalue 1, and we're going to look at the picture primarily. And then rotation, we'll go ahead and do a Varimax to make the higher order factors orthogonal. And then on options, what we'll want to do is sort by size. And so our question is, what clusters together at a higher level among STEM content disciplines? And we've also thrown in STEM career. Now, although in some sense, STEM career should be thought of as an output variable and the others are inputs. We'll get to that a little later. So what happened? We have a scree plot that looks like it's 2 factors. Do you agree? Something like that. 2 or 3 or 4 or 5. Because it's a little bit slippery slide like gems. And actually, the way this thing was constructed, we know they make pretty good independent constructs. But looks like there's a strong one here and probably a second one before we get to the third part of the slide. So I'm most anxious to see if it pulled out 2 components. Did it?
It did.
Okay, and so what are they when they're rotated? Well, STEM engineering, STEM tech, and STEM career interest all stick together at the higher order level. So what you think about engineering, what you think about technology is most closely associated with career among this group of students. And math and science are clustered together actually, and mostly independent of the other cluster. Okay, so this is higher order factor analysis, so it's easy this time, right? Okay, let's do higher order hierarchical cluster analysis. So we're going to do high class and throw these 5 in and see what it thinks. See if the view comes out the same or different. So we're going to put again in there just these 5 scales that we already know are reasonably good. And so the question here is going to be, hey, what swings with the pattern of careers? And the answer is, I don't know. I've never seen this done before. So we're going to change plots. And we want the dendrogram and horizontal and continue. And then we will let's cluster variables right now, but we may even have time to go back and do one on cases with this stuff. And so what do we see? Did all of you run this, or whoever is out there? And what we see at the bottom is, oh, nice picture. Well, there's definitely is something else sticking out there on the end. What is it? Ah, I knew it. Math is everywhere in the world different, and actually hated universally around the world. Feared is a better word. And actually, Marcinowitz, who in 1985 selected these adjective pairs, 12 of them, we just took the best 5. He did that from like Osgood's 137 adjectives that he created in, I think it was 1957. And so he said that these indicate involvement with the concept is really what's being measured by these semantic pairs. And so, or engagement. And so this is really the picture that I used to talk about. It breaks my heart because I was a math major and I thought it was fun, but oh man, almost nobody's engaged with math these days. So, so it's stringing way out on the end. This is a little different view, and it's interesting. Some of you know of Layla Mills. Anybody remember she graduated 4 years ago in the residential program? Well, this engineering and tech, they're still stuck together like before, so that kind of matches up. And then career joins them, so this cluster is the cluster I would keep because it matches the higher order factor analysis. Everybody okay? And then I would go, oh, well, going back over here to science and this, I don't know about that. But so at this level, it's meaningful. And it looks like science is added on, and then way out there, math is added on. Everybody okay? From this view. Pardon? Oh, well, understand here, and we'll go to the next step. I don't know why, Rick, unless maybe you chose a different interval or ordinal level or had default different on your machine. But these are arbitrary. Which way they swing, it's only where's the pivot point. That's all that's meaningful. So if this had been switched out here where tech was up here and engineering was down here, it's still the same. In fact, if this whole thing was pivoted so that engineering was stuck down here next to math, it's still the same, because think of this as a mobile that swings from the ceiling, and it's strings, and you can twist them anywhere. The relationships among the objects still remain the same no matter how you spin them. That's important for the next phase. Everybody okay? And Rick, are you okay, even if it's a little different? Okay, so Layla Mills' dissertation concluded. She studied her middle school where she was a math teacher. And that out of this instrument, that 2 things are important if you want your middle school kids to have a career in STEM. Number 1, they have to not hate math. They don't have to love math. They have to not hate math. Number 2, they have to still believe they're creative when they finish middle school. That's it. If you have those 2 things, then they have a pretty good chance they'll have a STEM career. And so this kind of, we don't have creative tendencies in here, but she did in her dissertation. Okay, so third view to figure this out, we hope, is what we haven't done yet tonight, multidimensional scaling. Everybody okay? And so, how do we do that? Well, it's under scale, and it's the last one, try all scale. Try that one first. If it blows up, try proc scale. And so in multidimensional scaling, we're going to put the same things in here. And remember, this is based on the correlation patterns. This technique, multidimensional scaling, is physically how close is math to science? How close is engineering to career? As opposed to the patterns of the responses. Okay, so what we want to do is data are not distances. We want to create distances from the data. these scores were semantic differentials 1 to 7, just like Likert 1 to 5 or something. So Euclidean distance measure is okay. On the options, I think it's up here, or maybe it's the model. If we'll look at the model is ordinal. Let's call it interval. I think we can assume it's an interval measure. And then right now this says put it in 2 dimensions, and that's okay. We'll start with that. The whole goal of multidimensional scaling is what's the minimum number of dimensions you need to adequately explain the distances between the objects. That is to fully recover the data in the matrix, and we'll explain that in a moment. So what's parsimonious? That is stingy but complete. And we're trying 2 dimensions as a start and see how it does. So we want to click on options and do the group plots. And then if Elaine's online, Elaine, we would say punch it. So is she? I don't know.
She is.
Oh, okay, deal. You can send her a chat and say, hey, we just said punch it for her. And so notice from the 2-dimensional solution, Daryl Ward, who wrote this, was a regression person, I think I mentioned. So he made it give you an R-squared, just like from a regression analysis. And it says 0.94. What does that mean? Well, it means that we can recover 94% of the distances across all the people among these objects if we use only 2 dimensions. And in fact, if we use the dimensional placement that's in the picture you're about to see, which is scroll down, 94% is pretty darn good. It's enough in psychometrics that we would say. If we use, so, no, don't, right here. This placement of the objects captures 94% of all of those people who responded and circled 1s and 7s. And if you did all the Euclidean distances between these, what would it be across all the people? And so in the data matrix, it can recover it. So how far are these from each other? Well, science is pretty far down here. Everybody see this? STEM science. And math is way up here in right field by itself. It's even worse than left field. There. And over here is career, tech, and engineering, which is what we saw in the first factor cluster, right? So that's consistent there. And if you remember in the dendrogram, if we will scroll back up, that we found these 3 clustered together in a cluster right here, and then science hung out here and math hung way out here. Okay, if you can imagine grabbing this thing and holding it from the ceiling, now if you'll scroll down, your good fit should be so that if you took this and made it a sheet on the floor, that you can hold the mobile and twirl the objects so that they exactly match these points. And so you actually need both the projection of the pattern matching onto the physical distances of the objects, in this case in 2-dimensional space, to fully explain the relationships among these objects. So if you can think of it, it's like this is on the floor and that's how far apart they are. But how long is the hoop that joins this to this as opposed to here to here? Well, you have to back up to the dendrogram and cluster analysis to figure that out. And if you will, for a moment. And so the answer is the loop from science from math to science is quite high. It goes like this. And the loop from math to everything else is just as high, but a different loop that branches there. Are you with me? It goes this way to all these 3. But the loop from engineering to tech is really short. They're a tight cluster. Still okay? Okay, so these are all 3 analysis techniques in this. And what I want you to do now, if you'll go back, 94% is good. How would we do if we smashed it into 1 dimension? maybe it's just as good. So try that. And then I want to go get a mobile to show you. I'll be right back. Maybe go ahead.
Misspeaking. There it is. I'm not very good with this mouse. I like minimum and maximum.
So what happened when we smashed it into one dimension? And
Well, it's in one line, but
Yeah.
you can still see how far apart they are.
yeah, and so math is way out here in left field or right field the way it was before. And these three are still clustered together. Notice something else got smashed into the
career.
career. Oh yeah, no, it's three. And then what's this? Engineering. Actually, it's science that got projected into the cluster with career. If we made this view, how much did we lose? And it's up there right above it where it tells us the total R squared. How much of the original data in the matrix? So we went from, here it is. Yeah, so we dropped from 94 to 88. Not a lot, but I would say from the picture we lost quite a bit because the two-dimensional picture looks so much like the dendrogram representation that I would keep 2 dimensions at 94%. And this is where what my former teacher Cattell would call the parsimonious solution. What's the most stingy and yet complete? Well, most stingy is 1 dimension and it would be okay, but you get a lot more complete if you go to 2. And I think I took this out the first night we were here, but this is a physical mobile made by Peter Fischer from the Netherlands about 4 or 5 years ago. And that was when Denise Schmidt from Iowa State had released the first instrument on TPAC. Denise, well, you will know her name because she's the new president of SITE for the next 3 years. But she's a psychometrician, sort of like me. And so Denise made this, do you know TPAC? Technology, pedagogy, and content knowledge, the 3 Venn diagrams and the model of how you teach teachers to use technology and also incorporate into, so the whole idea is at the base you start with content knowledge, and I believe teachers have to have that. And then you have to have pedagogical knowledge and pedagogy for certain kinds of content. So you put those 3 together and you get pedagogical content knowledge. And then what Mishra and Kohler did for Michigan State is they added the idea of, okay, well, when we have technology in the teaching mix, we have technological pedagogical content knowledge. And so Denise tried to make an instrument that would measure all those things as separate constructs. So Petra was in my Thanksgiving accelerated class and worked on that instrument. And she decided that actually the structure is like this in the TPAC instrument. And so I'll just read here at the top of the pyramid is leadership, and then what you call core TPAC. That is things that span up and down all across everything. And then what you call critical thinking ability that actually went across all these Venn diagrams. And then pedagogical science content knowledge. How do you teach science stuff? That's the core of a TPAC. And then general pedagogical knowledge. Do you have group discussion or just lecture? You know, all that kind of stuff. And then technological knowledge actually is the foundation. You have to have skills in how to run the computer and the technology, or else you're not going to get anywhere out of that. But then when you go down into the way that they relate according to the patterns, it's based on this. That it branches into 2 major branches. This one is called pedagogical knowledge, and it has 2 major branches off of it that then go into critical thinking and assessment of misconceptions in this branch. And then down here at the bottom is what she labeled pedagogical science content knowledge. So how all of these things actually relate to each other in patterns is over here. On this side is technological knowledge, and then core TPAC skills swing off of that. And then down here is the leadership attribute. And then down here, oh, this is funny. I'll pass this around. I didn't realize she had this picture on it. I should have counted off of that. And then she said, oh, a nice team to work with. And it has a picture of she and I and Yoko Bond. Okay, so Pinter was able to show that when you do a multi-dimensional scaling, you get a two-dimensional mapping, and that it was quite nicely projected when you could swing this around physically and show how it fits. So if you can remember that, it's quite okay if you make yourself a mobile. And you know you've got it right when you can twirl these branches and have them project, if you can imagine the light there onto the floor, because it's arbitrary and hierarchical clustering which way these things spin. None of the relationships are changed no matter how you spin them. The only way you know how to spin them is through multidimensional scaling, and to make them match the dots that are physical distances from each other in the projection down into the two-dimensional space. Now, if that's not bad enough, someone made the point in San Antonio last week that, well, gosh, what are these things that are the strings of the mobile? Well, actually, in some sense, you can call each of them a strand or a string or a thread or even a dimension if you don't make dimensions be straight lines. You know, they could just zigzag all over the place. That's all there is to this class. Make a little string figure and hang it over a two-dimensional representation. Any questions or comments for Debbie? This is actually a hard instrument to produce, but it's simple to look at because you all know STEM as a concept. And by the way, this only applies to the group that she was working in. We're trying to describe the group, not trying to judge the instrument now in general. So, okay, 5 more minutes for questions, comments. What do we do next? Eat more chicken. Well, we're done for the night. Let me see if I can turn this off. And thank you, everyone, for being a great audience. I'm wondering, we have enough, I think, to have class next week, do we not? And still some data to do?
Yeah.
Oh, yeah. I'm sorry. Next Thursday is 4th of July. There will be no class. No, I'm sorry. Next Tuesday, the next scheduled session. This session, we will not have class 4th of July next Tuesday, but the week after. And if other people want their analysis run, we'll do that first. If not, we'll jump into unidimensional scaling and start working with pair comparison. So I hope to see you all back in 2 weeks. Have a good 4th of July. Thanks for coming.
Thank you very much.
Oh, yeah, Jim. Yeah, let me turn this off if I can. Okay. Stop share. No, that's okay. The more stop video, end meeting. No, I'm going to stop recording.